Okay, today we are going to learn about basically just word problems with trig. So we're talking about angle of elevation and depression. Really not too important. The one thing we need to know is that we're always going to be looking up and looking down from the horizontal. And so with this first problem, it says from a hot air balloon 100 feet in the air, you look down and see a person waving at you at an angle of 25 degrees. How far is the person from you? And so whenever you see the word look down, or if we're up in the air looking down at something or anything like that, what's going to happen is we have to make sure that we are flipping our triangle upside down. So here's my attempt at drawing a hot air balloon. Looks more like a light bulb. And then if I see a person waving at me, there's that person waving at me. And so what I want to do is I want to draw this as a triangle, but I want to draw it as an upside down triangle, just like that. And so again, it says that I'm 100 feet up in the air, so my 100 feet is going to be talking about this distance right there. I'm looking down to the person at an angle of 25 degrees, which means this is a 25-degree angle. And then I want to figure out how far is the person from me. So I want to figure out the distance from the hot air balloon to the person. And so again, just like we've done before, two things I know, one thing I don't know. This is my hypotenuse, this is opposite, and this is going to be adjacent. And so the two things that I'm using are opposite and hypotenuse. So opposite and hypotenuse is sine, so I'm going to go sine of 25 is equal to opposite, which is 100, over x, which is what I'm trying to figure out. Multiply both sides by x, get x times the sine of 25 is equal to 100, and then divide both sides by the sine of 25. And so when I do that, I get x is equal to 236.62. And these are feet. Same thing with next problem that we have at the bottom. Airplanes flying 3-degree descent. So again, I've got an airplane up in the sky. And then I have a runway, so here's my runway down at the bottom. And again, I'm going on a 3-degree descent, which again is going to be from the horizontal, so I'm going to draw an upside down triangle like this. There's my right angle. The plane starts at 2,714 feet, and will land at the airport, which is 1,007 feet. So I just do 2,714 minus 1,007. And I get that my altitude is going to be 1,707 feet. That's the change. That's that vertical change from the height of the plane to the runway. I want to see 3-degree descent. So again, 3 degrees is right here. And so I want to find out how far the plane is from the runway. And so again, I'm still using my three things. Two things I know, one thing I don't know. That's going to be sine again, because this is hypotenuse and this is opposite. And so I can go sine of 3 is equal to 1,707 over top of x. Multiply both sides by x. Get x times the sine of 3 is equal to 1,707. Then divide both sides by the sine of 3. So I get x is equal to 32,616.2 feet. Flip over to the back of the notes. Again, see a rock climber climbing on a cliff at a 32-degree angle. You're 1,000 feet from the bottom of the cliff, and your eye level is 6 feet above the ground. So here I have a little rock. See a dude who's climbing. Looks like he's struggling a little bit. And again, this is going to be me. I am looking up at the dude, so I'm going to draw a regular triangle just like this. And so, again, I'm looking up at a 32-degree angle. I'm 1,000 feet away from the bottom of the cliff. There's my right angle. And so I want to figure out the height of the climber from the ground. And so, again, two things I know, one thing I don't know. X is opposite, 1,000 is adjacent, so I'm going to do tangent of 32 is equal to x over 1,000. Multiply both sides by 1,000 and get that x is equal to 624 point, hold on, .87 feet. And then the only thing that we need to make sure is with this problem, since that's just this distance, I'm missing this piece right here, which is going to be the height of me, which is 6 feet. And so I want to take my answer and I want to add 6 feet to it to get that the distance, the height of that climber is going to be 630.87 feet. Next one, an airplane seeing a life raft. Life raft at a 26-degree angle of depression. So again, I'm going to draw my airplane again. Down here is a life raft, but I can't draw a life raft, so I'm going to draw a banana-looking canoe. Here we go, let's do something better. There we go. Actually, it's going to be a sailboat. There we go. And so again, since I'm looking down from the plane, I'm going to draw a backwards or upside down triangle. 26-degree angle of depression. Plane's altitude is 3 kilometers. Figure out what's the plane's horizontal distance. Again, horizontal means sideways, left and right. And so again, these are the three things I'm using. So I'm going to use tangent because I've got opposite and adjacent. So I'm going to go tangent of 26 is equal to 3 over x. Multiply both sides by the bottom. Divide by the tangent of 26. I get x is equal to 6.15 kilometers. Second to last one, I'm standing on the ground looking up at a tree that's 50 feet tall at an angle of 42 degrees. How far away from the bottom of the tree? I'm 6 feet tall. So again, I'm right here looking at this tree. Pretty good looking tree, right? And then, so again, I'm looking up at it. So here's my triangle. Drawing a regular triangle since I'm looking up. Let's see, I'm looking up at 42 degrees. The tree, this entire thing, is 50 feet tall. And then I want to figure out x, how far I am away from the bottom of the tree. And so again, what I got to make sure is that I'm taking into consideration this length right here, which is 6. So if the entire thing is 50 going all the way up, and 6 is how tall I am, to figure out what this distance is right here, I'm going to take 50 and subtract 6. And so just this piece right here of the triangle is going to be 44. So this piece right here is going to be 44. Again, I'm using two things I know, one thing I don't know. I'm going to use tangent because I've got opposite and adjacent. So tangent of 42 is equal to 44 over x. Multiply both sides by x, divide by the tangent of 42. Skipping a step there, but I think we're good with that. And so I get x, the distance I am away from the tree, is 48.87. And then the last one is looking down a zip line that's 400 feet long diagonally and 30 feet high. What's the angle of the zip line? And so when I do this, again, here I am up at the top of this tower thing. Here is a zip line going down. And again, if I'm going down, I want to do an upside down triangle like that. So I'm trying to figure out the angle that I'm going down at from the horizontal. I know I'm 30 feet high, so this is 30. And then it's 400 feet diagonally, so I know my hypotenuse is going to be 400. Three things I know. And so I've got opposite and hypotenuse, so I'm going to go sine of x is equal to 30 over 400. And so again, I'm going to go second sine, so inverse sine, 30 over 400. And that'll get me an angle of 4.3 degrees.